Exponential distribution. X is said to have an exponential distribution with parameter lambda. That's what we call the rate parameter. If f of x is equal to lambda multiplied by e raised negative lambda x. What is lowercase f of x? It's the density function. Okay, I'll do integration for you this one time. So we want to verify that f of x is a valid PDF. So it will be a valid PDF if I integrate the density and it must equal 1. If it doesn't equal 1, it's not a PDF. This is the same concept of saying area under the curve is 1, right? So integrate from 0 to infinity lambda e raised minus lambda x dx. Lambda is a constant. If I set u to be negative lambda x, du is negative lambda times dx. So dx would be du divided by negative lambda. When x is 0, u is 0. When x is infinity, we have negative infinity. E raised u du over negative lambda. Yes? Lambda and lambda will get cancelled. Negative integral 0 to negative infinity, e raised u du. The integral of e raised x is e raised x. So we will have e raised u, lower limit is 0, upper limit minus infinity. What is limit u approaches negative infinity, e raised u? Upper limit 0 minus lower limit e raised 0 is 1 minus times minus is 1 minus times minus 1 is 1, so it is a valid PDF. Yes?
Why did the infinity become negative?
Change of limits. So since I'm using u substitution, when x is 0, u is 0. When x is infinity, negative lambda times infinity, negative infinity. Good. How do we find the CDF? Same process, but instead, I'm going to erase this. Instead of integrating over the entire support, we're going to integrate it from 0 up to x, give a dummy variable, I'll call f of u to u. So we're going to integrate the function, the PDF, which we have verified is valid. So take this, plug it in here, evaluate it between the two limits. You will get a function as an answer, and that function will be the CDF function. Give you a few minutes for you to try. Okay, so integral 0 to x, u is just a dummy variable, you can call it a if you want. So the density is lambda e raised minus lambda u to u. Lambda is a constant, integral 0 to x, e raised minus lambda u to u. That is the standard integral for any value a. The integral is simply e raised ax divided by a. In place of a, I have negative lambda, so this would be lambda e raised negative lambda u divided by negative lambda. Evaluated between 0 and x. The lambdas would go away. So minus. There is a minus out, so that's why I'm putting a minus here. Upper limit, u is equal to x. X goes in here. E raised minus lambda x. Minus the lower limit, 0. 0 goes in there. E raised minus lambda times 0, 0. E raised 0, 1. Good? Yes.
I'm confused why we use substitution over there, but over here we do something different. Only the same thing.
And because that's an improper over there.
You mean?
Because it's to infinity.
No, so this is also u substitution. But I just skipped a step and I said, you know, now that we've done that, this is the standard integral. So how do I get this answer over here? I have to do u substitution here to get that. If I rewrite this, I'll have 1 minus e raised minus lambda x. Correct. Greater than 0. Good. And f of x must satisfy all properties of CDF. F of x, uppercase f of x, is continuous, so of course it is going to be right continuous. Not a problem. It is an increasing function. You can use a derivative test and you'll see this increasing. Limit sorry, positive infinity. What happens if x is approaching positive infinity? It will become 1 because that is going to become 0. So you would end up getting 1 minus 0, you get 1. So it is monotonically increasing from 0. So since the support is defined for x greater than 0, when x approaches negative infinity, it'll just be 0 for any value below that. So on this endpoint, it'll satisfy the properties of CDF. It'll do it on the right endpoint. So we have a valid CDF also. How do we go from a CDF to a survival function? I use the notation g of x. is simply the complement of the CDF. So 1 minus 1 minus e raised minus lambda x. You get e raised minus lambda x. The support is still the same. That will not change.